So let us start with the introduction to physics. Like I said about the introduction aspect of physics, we need it to understand what physics is all about. And also, as I said, that before you start this journey of physics, you need to watch the basis of vector and that of calculus. So now let's introduce ourselves to physics. To be an advanced student in physics, you have to start from the basis. So the first thing we're going to do here is just to define physics in my own way. Not necessarily you define it in the way I want to define it, but basically for beginners, if you have those that are just starting, we define physics as a science. Physics is the science that is concerned with the behavior of matter. So just like our chemistry, that is also defined in terms of matter, we also define physics in terms of matter because it's concerned majorly with how matter intermolecular forces relate, and we study it, though there are some numerical aspects of physics, which is as a result of what we conclude from experiment to, more or less like your chemistry. So we define matter for those that are just starting year 10, that is SS1, as anything that has mass and occupies space. So this is just a simple, or one of the simplest way you can define physics. I'm talking about that. I haven't said that it deals with science, and it's a science subject which deals with how matter interrelates. And we all know the definition of matter can be mass or weight, which we are still going to differentiate between them as we further under the topic of physics. Now, we know physics will definitely have branches, which is also part of what is on this slide as prepared by the students. Now, talking about branches of physics, we can keep that in notes too, branches of physics. Now, in nature, we can say we have 5 to 6 branches, but it says 6 major of physics, which we are going to be considering one by one on this channel. So the aim of the channel is to help you guys, to help you through what you are going to learn in your schools. And that is one thing that is very important for beginner. You have to pick interest in it. You don't run away from the class, respect your teacher, because you need to have foundation. What you have learned will increase when you come online to come and learn more. So you have to have the basic knowledge, do the experiment. I have some experiment video I will also be uploading in the later part of the slide. Not here, but in current videos, you are going to be seeing them. I have a lot of classroom videos also that will help you. I will add them to your knowledge so that it will increase the rate at which you want to understand the whole physics. Physics for high school, for those that are in secondary school, is what I'm focusing on. And majorly, I'm also focusing on those that are doing A-level physics, which is IDMB and the JUPEP in our own way here. So I will be taking it to that level with respect to what is in your syllabus, because I don't want to go more than what is required, so that everybody will benefit from this channel. Now, about branches of physics, like I said, we have 6 branches. I'm going to highlight them. The first one we are going to talk about is one we call mechanics, or we say mechanics. So about mechanics, it's just an aspect that deals with the study of motion, the movement, the change in direction of an object or a particle or system of bodies. So mechanics is the first aspect, and it's even one of the most important aspects in secondary or high school physics, which is very important. You need to keep it in mind. Even A-level physics, 001, it's all about mechanics. So please, it's very wide. I can tell you, first part of our physics video will be on mechanics. Then the later part, we talk about the 002, which will be on it. So the next branches of physics, you can also study all these branches. Keep it at the back of your mind, can be studied as a course. Now, the next is it. So in fact, you can say it and thermodynamics, the way we call it. So the second part of our video slide will be majorly focusing on heat and thermodynamics. And you know about heat, you are going to understand a lot of things about it and behavior of different states of matters and the numerical values. All these are going to be talked, about. The next one, which we are going to operate immediately after that, which is the third branch of physics, is going to be what we call optics. Optics, when you hear the word optics, some people will write it as light. Yes. So we are going to go with a close study of it, measurement of light. They are fine. So about light, we are going to talk about that. Is another branch, which is also very, very crucial. The next one will be what we call electricity or electric current. From your junior classes, electricity, you have studied a little bit about electricity. Now in physics, we are going to look into the whole thing you need to know about electricity that will prepare you for your university course. So the next, which is the fifth one, we call, you can say we have atomic physics. Atomic physics. Now, more or less like your chemistry aspect, that is talking about the composition of atom and the behavioral pattern of atom inside different media. So we are going to consider different names of scientists and what they discover. So under atomic physics, we also study a lot about radioactive substance and some other things which you need to know on atoms and its composition. Then the sixth one you can also write is called solar physics. That is the solar system. We are going to put into consideration to the solar system. So these bring about, or some people say quantum physics, anyhow you want to call it. So these bring about all the branches which you need to keep in mind, because as a beginner, you might be asked in your first exam, for those that are just starting year 10, that what are the branches of physics? Define physics, define matter. So this is the definition of physics branches and the definition of physics as a science that is concerned with behavioral pattern of matter. So keep all these things at the back of your mind. They are not difficult to know. And as we move on under each study, it is going to be a lengthy video, which are going to be prepared in terms of playlist. So you just go into the playlist, you can just search for what you need under the channel, you are going to see them. So as we update them on a daily basis. Now, we move to the next point we can also talk about, which is also very important for you to understand, which we call quantities. So it's a sub slide, which is also under quantities. Now, about quantities, you should understand, we say physical quantities. Now, in physics, we define quantities as what we measure. So we can say physics is all about our quantity. I said physics. Just write what I'm saying, guys. Quantity is what we measure in physics. Quantity is what we measure in physics. So any physical quantity that is measured is called what? Any physical property that is measured is called quantity. So keep it at the back of your mind. It's also very important. In fact, we denote, because if I talk about quantity, I need to talk about units. Though I will still talk about physical, I'll talk about physical quantity in terms of two. There are two types of quantity for your level. As you move to the advanced level, you will know that there are three types. But for now, I'm only limiting myself to what is provided in your syllabus. So about your syllabus, quantities are divided, or physical quantities, the way you put it, are divided into two types. We have the first one we call the scalar quantities or quantity, and the second one you call the vector quantity. Now, if you have watched the video in accordance, I told you watch on vector before you start introduction to physics. Now you will understand what we call vector, because we have explained how it happens. So writing this in the definition form, we say scalar quantities. Let's just put down a note, because I know some of us are just seeing all this for the first time. Scalar quantity, they are those ones that only have or possesses, let's say they are quantity that have magnitude only. I will just abbreviate because of notes. Magnitude only. When we say magnitude only, we mean the size. It's just what the size. So I want to talk about the other one you call vector. About vector quantities. They are those that have both magnitude and they also illustrate what direction, which we have discussed under the chapter of what magnitude and direction. Under the vector basics, we've talked about this very well. So my point here is that talking about examples, the way I always teach beginner when I was still in classroom is for you to understand that when we talk about something pointing out direction and also have a size, which is a physical property of it, you can say it is a vector. And when you talk about these quantities, as you meet them, you are going to understand them better. Now, if I start listing different things that you are hearing for your first time, it will not make sense. So for now, I will only give you simple examples as example of scalar and vector, which will help you in growth. There is no way we introduce you to anything, any property, any physical quantity that we are not going to tell you maybe scalar or vector. By its composition, by its definition, and by the concept we want to explain, we'll tell you if it is scalar or vector. Now, for now, like example, the simplest form of example we have given before, if you remember, we talked about, first thing we talk about distance and displacement. So when you talk about distance, you are talking about gap between two positions. The first thing, because in the next video slide, when we start the kinematics, we talk about distance and displacement. We talk about speed and velocity. And we talk about acceleration. Now, these are important physical terms that you are going to start with for understanding's sake. What do I mean? For understanding's sake, you have to start with all these four stuff: distance, gap between two positions, displacement, shortest distance between 2 points. I'll provide videos for all those one under kinematics you can watch. Or the distance traveled in a particular direction, which is the common definition you see in your text material. Yes, whenever there is a direction, it is a vector. So when you think about distance, you think about displacement. So distance is scalar. If you want to write the example now, for beginners, as we are starting, we talk about distance here. Here, you talk about what? Displacement. I hope you are following. Another good thing, when you talk about speed and you talk about velocity, we are still coming to their symbols and their units. I'm coming that next thing I'll talk about is measurement and units. Now, another good example, like I said, I will not write up. As we continue in these write-up or in this slide, we are going to be adding to them. Because when we start measuring, we're talking about other physical quantity examples, we are now going to talk about if it is scalar and why is this scalar, you understand. So any physical property that has size alone without having a particular direction is called scalar. And those that can be measured in both what we call the direction and in their physical quantity as the size, which is magnitude, we said they are vector, which we have talked about at the vector slide, which I asked you to watch before this. So now, be that as it may, we say in physics that a velocity, we say speed here, and here we say velocity. And the last one I want to talk about, if you say, here you say acceleration. Now, about acceleration, we are still going to talk about all these under kinematic a lot. Now, here you can talk about mass and talk about every other thing that you can continue writing. I will be adding to them. Now, when we talk about acceleration, something brings about acceleration. Body will gain velocity as it is what? It gains velocity. The next thing you expect for that thing is what? As it is changing with respect to a time function, it will start accelerating. And before you can gain velocity, there must be a force. So that is why I say under the topics of dynamics and kinematics, we are going to break all these things down into pieces. There is a car at rest. Before the car starts moving and and gain some impact of velocity, there must be an applied force. That particular force giving velocity as velocity increase, it brings about acceleration. Then you can see acceleration is moving in the direction, velocity starts moving in a particular direction, That is why it is vector. All those things are very important. And we are going to break them down as a beginner on kinematics and dynamics. And we'll give you different laws. Physics is all about law. Now, be that as it may, because we have a long way to go in this video about introduction. So another quick thing I can give to you is that, in fact, when we talk about what we measure, that is, talking about measurement and unit, you can also keep in mind that it's talking about measurement and unit. Now, when we talk about measurement and unit, we said quantity is what we measure. In fact, in early classes, students should know that the formula we give to quantity is always equals to Q is equals to NS. Quantity is equals to N stands for the numerical value. And keep this in mind, is also important, numerical value. And the S I'm talking about here is talking about the symbol, or you say the unit. Symbols or the unit. So my point here is that whatever you want to measure is going to have a numerical value, and you must put a unit at its back. So talking about units now, quantity is what you measure. Now, you cannot measure a quantity without adding a unit to it. This is the relationship we said. So now when we talk about units, we also group units into two types. So about units, we have what we call the fundamental unit. We also have what we call derived units. So I will take you through this one by one. And these are the fundamental part of the syllabus. Now, look at what I said unit. I said quantities are what we measure. They must have numerical value and they must have what this. Now, let's quickly go back to what I was explaining here. Now, when you say you are measuring a distance, now, for example, you say you measure a distance of, taking an instance, 2 kilometers. Can you see? This 2 here is a numerical, numerical value, numerical, and kilometer is the unit. So then the total of 2 kilometers is a quantity because that is the measurement you are taking. So that is what I'm trying to say for understanding's sake. So my point here is that if somebody measures a distance of 2 kilometers, without telling us the direction at which you are measuring it, we take distance as what a scalar quantity. Or if I say I'm measuring 2 kilometers in the direction of north, for example, up north, now that means I'm telling you a distance in a particular direction, and we don't call that distance again, we call it has been displaced, displacement. And the displacement is now what we call a vector quantity. So these are ways in which you can start learning it from the scratch. And that is why we are doing this. So about this unit, which we are putting at the back of each quantity that we are measuring. Are you with me? This particular unit we are talking about are now also grouped into two, just like the way you group your quantity into two. So about fundamental units from its word, from the word itself, when you say fundamental, that is basics. They cannot be derived or they cannot be approached. They are the basis of units. I hope you are writing. Then talking about that, if we go by that, we can now say if what units that cannot be derived or approached by any means. In fact, in physics, there is a universal unit for all quantities. I hope you are following. So this universal unit for all quantities is generally accepted and it's called SI unit. Some people say symbolic interpretation. Yes, SI unit. So this is what you need to keep in mind. Unit that cannot be derived or approached by any formula is called fundamental units. So and we have a lot of examples, but majorly for now, we are going to do it in tabular form for you to understand. So I will start from fundamental unit in tabular form. I leave some example, which we are going to break down. Then let's do that in the next slide. Fine. Yeah, we are talking about fundamental unit, and about fundamental unit, we want to talk about we want to talk about fundamental unit in terms of examples. So fundamental unit in continuation to what we are writing. So we take the quantity, we take the symbol, and we take we have the SI units, the units. I'll just list some fundamental quantities which are very important for you. The first three from elementary classes I've placed. The basis of fundamental unit is taken as mass, length, and time, which we are still going to talk about on that dimension very well. Mass is denoted by M, length is L, and time is T. We can put it there just for us to have a lot of things to write. We have a mass. The symbol of mass is M. The unit of mass is measured in kilogram. This kilogram is symbolized in the unit of kg. Then length. Length from early classes, we have L, which is measured in meter, you write as M. And time. Time is denoted by small t, then it is measured in seconds. The next one we can write is current. These are now what is important for you to keep in mind. Current is written as capital letter I, and it's measured in amperes, which we denote by A. For the spellings, is given as AMPERE. I hope you are there. Then the next one, we have temperature, which is the measure of hotness and coldness you've learned in junior classes. Temperature is measured in Kelvin. It's symbolized by T. It's measured in Kelvin. Kelvin, just like your Kelvin, your friend, if you have a friend named Kelvin. So that's Kelvin. The next one, we can write amount of substance. Amount of substance. There's also basis, which is fundamental. We denote that by A. It is measured in moles. We write mole as MOL, and the spelling is MOLES. Another one we can also write, which is quite important, is what we call intensity of light. Intensity of light. About intensity of light, we also denote that by I, and it is measured in candela. Right? Candela as CD. Candela is spelled the way I have said it. That is candela. So these are the fundamental quantities you can keep at the back of your mind for now. There are other fundamental quantities, but for now, we are only limiting ourselves to those ones we think will be needed in deriving other form of units. And I said it is not only fundamental units that we have, we also have another type of unit we call what? Derived unit. Now, about the derived unit, we said they contain two or more fundamental units. You can keep a note, they contain two or more fundamental units. Now they contain two or more fundamental units. That means what we're talking about is that we actually take them from what? From the fundamental unit, which was now combined together. That is why most of the time we explain fundamental unit before we talk about the derived units. Now about the other time I was telling you about mass, length, and time is the basis. In fact, most of your textbooks or text material will tell you it is what? The international agreed fundamental unit. That is, it is universally what approved. So always keep it at the back of your mind. Mass, length, and time is the basis, and it is SI unit. We say you cannot measure anything without putting SI unit in physics. In fact, if you are doing numericals calculation and you did not put SI units, your physics teacher is not strict, because without you putting units, he or she is going to what? Remove your mark. So for the international agreed system or convention, this is internationally agreed SI. We have a SI unit. These three are what everywhere you go. Mass is measured in kilogram, length is measured in meter, and time is measured is seconds. So talking about this contains two or more fundamental units. Not to waste our time, we are going to follow the same path. Now, following the same path, we can now say from here, we take it one by one to understand this thing. Now, if we want to talk about area, look at this area. I'm talking quantities, symbols, and units. Area. From junior classes, we know area is always a combination of two lengths, either length times breadth, that is meter times meter. So, and it will be what? Area, I said area is written as A, which is the symbol, and it will be meter times meter, you say what? Meter square. Volume, junior classes. Volume is what? Meter times meter times meter. Length times breadth times height, they are all meter. Length is meter. Distance is meter, because distance is measured in terms of length. So volume, what is that? I said volume is length. You denote volume by V, and this is the symbol, is meter cube. The next ones are those ones that you have to what? Understand from the concept of formula, which we talk about. We talk about velocity and speed. We say velocity is the rate of change of displacement with time. Velocity we denote by V. In physics, you can keep it at the back of your mind. So if you write velocity now, which is also the same thing as speed, but the difference between speed and velocity, we have talked about it in previous slides. One is scalar and one is a vector. So in denotation in numerical, the only thing you can use, if you have watched the vector video, we put something on top of what? On top of vector. So this will tell you that this is velocity. It is not needed, but it may be stated in some questions as we grow in the word understanding of it. So velocity we write also as V. You can put vector form, but like I said, it is not important. Now, you can see we have talked about distance. Distance is length, which is measured in meter, divided by time is seconds. So you can write it as meters/seconds. Or from your math class, ms raised to power -1, which is the most important thing you need to know. So if you write meters per second, that is very correct. I hope you are following. Now, the next thing is what you can see. It contains two, length and time. So the next one we can also write there are lots, but I want to be taking it with respect to those important ones that you are going to see. We can write acceleration for a beginner class. We said when body has gained somewhat velocity, it starts accelerating with respect to time. So acceleration is from what? A body that has a velocity divided by its time. If I were you, I would just do it direct. I know velocity is meters per second, and time is also seconds. -1 will give you meters per second squared. Some people will write it like this, or ms -2. If you don't understand how I come about ms -1, write your own as m/s over x, where you change the division sign to multiplication sign, the s under will flip over and come to the flip. So here, acceleration we denote by small a, can put the vector form as a vector quantity. Understanding's sake, that is why we do this. So now you can write as meters per second squared. Like I said, there are lots of derived units. Please note, force is also a derived unit. But in measurement of force, we measure it in Newton. Newton is the name of a scientist, which is going to be the one that will take us through the study of our mechanics, as in its laws are going to be very, very important in understanding mechanics. Very, very important. So about that, we can also write other ones, which I think for now you might need. Let's talk about what we call the pressure acting on the body. Pressure is given as the total force of the body divided by area. Force, I said, is measured in Newton. Area is measured in what? We've written that meter squared. So that is Newton per meter squared, which you can write as Nm -2. So you can write pressure. You can continue to write as many we want to write. And write it as P. And we write the unit is Newton per meter. So any unit that has different what, that has a more than one fundamental unit is called a derived unit. We can write, we can continue to write and continue to write and continue to write. But for now, let's stop here about derived units. Others, we are going to get to know about them as we grow in this topic. So next, this will now lead us to the next slide, which I think is also what it's time for us to move to the next slide and discuss about the other part. Because this is just the first part of the introduction into quantities and units, which we have done. So let's move to the next slide and see what we. Yeah, about the next slide here, we have what we call mass and weight. Now, in the beginning of the syllabus, you need to also understand, as part of the introduction, what is mass and what is weight, and how can you differentiate. The first thing we are going to write is about defining mass, and we define weight. So in definition, we give in physics to mass. We say mass is the quantity, or the measure of quantity, is a physical quantity, is the quantity of matter in the body. The mass of a body is the measure of the quantity of matter in the body. Later, we can also define mass in any other way when we start studying motion and talking about size, igniting of motion. We can define mass also in measure of what? Measure of what we call the inertia. Inertia, you might what be hearing that for the first time. But for now, let's take it in this one. Matter, anything that has mass. Space. So the amount of matter you have in your body is your mass. And that is why we say it is a scalar quantity. It is a scalar quantity. Because it's measured mass, which is scalar. So now we can define weight also before we now make a tabular form, which will be all I will talk about here. I'm not going to waste time on with mass and weight. Weight, we can say weight is the product of mass and acceleration due to gravity. First time we are given definition in terms of formula. Now in physics, it is also very good for you to keep it at the back of your mind that whenever you talk about definition, you can also define with respect to the formula. Now, weight is the measure of mass and what? Acceleration due to gravity. You can see inside the weight, you're having mass, which is a physical property, and you're having acceleration, which we said is a measure of direction. Then the next thing is gravity. What is gravity? There's always a belief which also works. You can also, there's a lot of experiments to check what your teacher is saying. That's, as I mean, simple experiment that will not cost you too much. Now, there's always this belief that what you throw up will always come down, right? Very good. Now, looking from that aspect, you can say well, there is always a particular force that is always acting in that particular direction that always brings something that is going up towards the downward direction. Excuse me. Now, if you look at that, that particular thing is said to be the weight. Now, and what we call about what the Earth, because I'm taking this video on the planet Earth, we are living in the planet Earth. Do you understand? Is always having what we call a particular force we call the gravitational force, which is also part of the mechanism. When we get to the study of gravitation, we are going to tell you that well, gravity varies from one particular point to another. When something is placed upward, we can tell you that well, the amount of gravity that will be acting on it will be less than the one that what you understand. So all these we are going to what consider, but the direction of the weight of a body of any material is always, you can see this stylus pen is always acting downward. So because of that, we say as you move from one place to another, because there's a direction, you understand, what you see is that what there will be change in the weight of your body because of gravity, the force that acts between the body and the earth and where you are, you understand. So it's called gravitational force. Now, this particular force always acts downward. So that is why whenever something is going upward, we say it is what going against gravity. We are still in the foundational class. I hope you are getting this. So keep it at the back of your mind for now. There are a lot of things that affect gravity. Not only the whole weight. Yes, height, the altitude, fine. There are other things that also affect gravity apart from that, which we are going to talk about under gravitation, especially for advanced students. And we have also laws that govern gravitation. Now, let's leave that aside. Now we can say this numerical form now. We denote weight. Weight is a vector quantity from our explanation. We can write it is a vector quantity. It is a vector quantity. Because it is a vector quantity, you know what it means. It has magnitude and direction. So I say it's the product. Weight W is the product of what? Mass, M, and gravity, G. This is the way you express that numerically. And you can also keep this in mind because it's going to help you in the growth of physics understanding. Now, to understand this very well, we can make a table or a tabular form for the understanding of this whole story, to differentiate between mass and weight, because it is common everywhere you go in your exams. That is the first part. Your teacher will ask you to state differences between mass and weight. So let's do that now, so that when you face that, you won't have any issue. So we take mass on the LHS. LHS means left-hand side. That is the mirror image. When I do this, you know, my left is your right. Note that. Mass, and here we have the weight. Now, about mass, we can say mass from what we have written there. We say mass is a scalar quantity. So this is a scalar quantity. You form your note. It's a scalar, and this is what? Vector. Another thing I can write, which I've not written there, I will still write what I've written there to make it whole. Now, mass is measuring what? Measuring kilogram. Please form your note, jot down, which is written as kg, whereby weight is measured, weight is a force, measuring Newton. Newton is written as N in joules. The third one you can also write is that the composition of mass. If you want to measure the mass of your body, the instrument we use to measure mass is called chemical balance. Chemical balance, or sometimes we call it a beam balance, measuring, or sometimes we call it a lever balance. So anyhow you call it, this is what we use to measure mass of the body. But when you measure weight, you only use what we call the spring balance, which I believe you've seen before, especially if you want to measure your weight, that particular thing, your aboki caliper, and then you have the spring balance. We also call it Hooke's balance. Hooke's balance. Hooke's balance. So either spring balance or Hooke's balance, you are saying the same thing. Another important thing you can write about mass and weight is that the mass of a body is constant. Mass of a body is quite very important. Of a body is constant. So mass don't change. Whereby weight varies. Weight varies from one place to another. So the weight of a body changes, like I've explained, because of gravity. That is why weight will change from one point to another. Very important for students to keep that up. And the last one, to make it 5, because most of the examiner will ask you to do 5, you can use the definition. Mass is the quantity of matter in the body. Weight is the product of mass and gravity. So I hope you understand the difference between mass and weight, which is also part of the fundamental on physics. So we move to the next one. Wow. Conversion and unit. Now, we've talked about unit. We've talked about quantity. We said quantity is what we measure. Unit is what we add to what is the measure of the numerical value, or let's say the interpretation. Or unit can be defined as a what? As a composition of what? Of quantity. When you measure any quantity, you have to put units. So now, there is a general term or a universally agreed unit for all dimension. When I say dimension, I mean quantities. Please, terminologies are used in physics. So I'm trying to use those basic words because we are taking basic chapter for understanding's sake. Now, about that, if you have another unit, which is not the SI unit, which I call the symbolic interpretation, which is mostly accepted for every quantity you measure, or every dimension you are measuring. So you should always keep it in mind that when you talk about units, the SI unit is not the only unit. There are other units of measurement, but it is not acceptable. And when you have a unit that is not in the standard unit, you have to convert. So when we talk about conversion and units, because of this slide that was prepared, we are talking about changing one form of unit to its natural or to the international agreed unit. So that will now bring us to calculation, which I call numericals, and that will test our knowledge of what? Physics, because physics is mostly numericals. It is not about that. And that's why most people will say there are too many formulas. No. If you understand it, you will always know how to go about it and get your answers to any numerical. In fact, numericals are always very easy to do if the understanding of the topic is good. So about that, before I talk about that, I think we still need to talk. And here, also, you can see from what was prepared here, we talk about the meter rule, the caliper, and the micrometer. So a quick one before I go to conversion, which is the calculation. I can tell you categorically that when we measure length, let's start with length. There are three instruments we use for measuring length. We say length is measured in meter, which is a distance. It is the gap between two positions. You can write, for definition's sake, the gap between two positions is called length. And to measure length in physics, we have three things we use. The first one is what is written there, the meter rule, which is popularly called the ruler. This is also known as the ruler. This is the one at the middle here. That is according to what we have here. I like this student that prepared this slide. He or she did well. Now, the meter rule, looking at the meter rule is what measures what measures length. One of those instruments that measure length. But there are limitations and there are advantages. You need to understand. So about meter rule, I won't talk too much because I know we might have studied this in our early classes. It's a ruler and it only measures, the important thing, only measures length up to 1 decimal place. So the measure of length up to 1 decimal place is what is carried out by your ruler, which I believe you all know very well. So if you look at what I'm saying, if you want to measure a dimension of 2.0 centimeter, ruler are graduated in centimeter, I mean the units. You can see, and length is not in centimeter. What do? You convert to meter. And that is what we call about conversion, units, and different instruments that we have. So my dear student, be that as it may, when we talk about units, we should keep it at the back of our mind that this unit of measurement might not be in the SI unit, it might be in CTS system, and we have to convert back to its measurement. So now, ruler measures up to, which we call meter, up to 1 decimal place. And why is because you cannot measure, you can see after decimal point, there's one number. That is 1 decimal place for those who don't. So, and there are limitations. There are some lengths that are shorter, which ruler cannot measure. And another thing is it only have it has 1 scale. In ruler, you only have 1 scale. Ruler has only 1 scale. And also have only 1 scale. Another thing which I think you need to know here, just for understanding's sake, is the error. Now, in physics, when we talk about errors, there are different types of errors. I'm limiting myself to what the syllabus require. And if it is on what the syllabus require, you need to know that when we talk about errors, we talk about error due to length. Now, an error due to length is always measured. In your mathematics, your teacher might have talked about this by 1/2, that is half of the error, which can be maximum, that is plus, or minimum, that is minus. Yes, we are starting numerical. Yes, I know you are saying how. We are starting calculation a little bit, and that is what we have here. Now, what I'm trying to say now is that whenever you want to calculate error of any dimension, what we use is the simplest length of that stuff. The simplest length that thing can measure. We go by half of it. In your ruler, for example, you say 1/2 half of the simplest dimension you can measure is 1 in your rule in centimeter. As 1 divided by 2 is 0.5 centimeter. This is the error. But you can say maximum error can be plus or minus. So if this ruler is subjected to what? An error of 0.5. So then maybe if you are now measure a length of 24 centimeter, for example, I just want to take you through this and being signaled that the time is not favorable. So now 24 centimeter, if you look at 24 centimeter, you want to have an error now. If you look at the error now, if it is subjected to an error of 4.5, so you can have maximum error and you can have minimum error. I hope you are following. So the maximum error will now be equals to find 24 plus, that is why we wrote plus here, 4.5, and that will be 24.5. While the minimum error will now be 24 minus 4.5, which will be the minimum error in the scale. I hope all students here can use ruler to measure length horizontally or vertically. So that is that. Then the next one, which is quite very important, is what is it? It is not drawn well, but we can still try and visualize what we call a venier caliper. You know, some of you, you've seen this before in your physics laboratory, or maybe in the workshop, or during your basic science class in junior classes. Now, about venier caliper, it measures up to 2 decimal places. Quite important for us to keep that. Measures up to 2 decimal places. And majorly, it is used for measuring the what? We said the diameter of a rod. So you can say measuring the diameter of a rod. Because it measures up to 2 decimal places, you can say maybe you have, let's say we have a 2.25 centimeter can be measured. In your exam, your teacher might ask you that which of the following can what measure this particular length. What you need to understand from there is what? Just check, you know, what the decimal place of each of the lengths. If it is 1 decimal place, it's going to be a ruler. If it is 2 decimal places, it's going to be a vernier caliper. And one thing about vernier caliper, like I said, is that well, it's not like the other one that has only 1 scale. So in a vernier caliper, we can say it has up to what? Two scales. Now, the scales are divided into 2 and they have name. And the first scale we call, excuse me, the main scale. I'll show you. The second scale we call the vernier scale. Now, main scale and the vernier scale. Now, you should keep in mind that the vernier scale is like divided into 1/10 of the main scale. As you can see here, up we go. Up here, the one on top, you can see is like placing a ruler in front of it, then this is the caliper. So it is composition of 2 scales. So up here is the main scale. This is the main scale. And down here is the vernier scale, which from calculation is always 1/10 of it. So now my point here, my dear student, is that because of that, when you want to measure a vernier caliper, it's not that straight, like the way you use your ruler to measure. And we do that in most of the schools. And for those of us that are not privileged to have it or see, we've not seen it before, it's still not difficult for you to understand how we measure it. The first thing is when we place a caliper on top of anything you want to measure, maybe inner diameter of a test tube. Yeah, another thing, and also measure inner diameter, majorly for diameters of a test tube. You can see the way it is, so it can enter into it. So now my point is our test tube. I hope you have seen a test tube before, and if not, in your chemistry class, I'm still hoping you are going to see it. So now the scale, like I said, main scale, which is the main read. Now look at this very carefully. I know it is not drawn to scale. I will still try and draw out a simple one you are going to see in your test material, especially during examination, the way it will be seen directly. You can see this is where this vernier scale started. I hope you can see where I'm pointing. Very good. Now, this is the main scale. you are going to count the male scale. That is the scale before this vernier scale was placed. If this is 0 here, whatever is here, this is 10, and this will be 10.1, 10.2 before this particular scale was placed. So that is the reading on the main scale. Whereas if you want to read the vernier scale, you now start looking from this to this. You now look for point of intersection. Point of what? Intersection. So where this scale intersects with the one up here is the reading you give to the vernier scale. A good example I'll quickly give to you for understanding a rough diagram, just for you to see what I'm talking about is, let's take this as the main scale and take this as the vernier scale. The main scale, let me say this is starting from 0. Let's use something different. Then we say this is 1, this is 2, then we say this is 2. Yes. So I'll give you this as 0.0, this as 1, this as 2, then this is the scale before that. Then the other scale here is now 1, 2, 3, 4, 5. 1, 2, 3. At this point, it's now intersecting. So I continue my scale on the top, trying to do something that you will see very well. Then nothing is intersecting. 2, 3, 4, 5, 6. Then let me just put it like that, just for a scale where the two are intersecting. If I want to read my main scale for understanding's sake, the way I can break it down for you, this is the dimension of my main scale. So I will say main scale reading is equals to, I'm reading this dimension from this point to this point. That is how we read it. So here, I'll say if this is 0, this is 1, this is 2, then this will be 2.1, 2.2 before this started. So I'll write that, it's 2 decimal place 2.20 in centimeter. Now, the vernier scale, which is, I said, it is 1/10 of the main scale. So where is the vernier scale? This is the vernier scale. Inside here, now start, we are looking for where it intersects. Your own is just to count and check where it is intersecting with what is up here. You can see there is a point of intersection here at this 6 here. So what I'll do here is just, I'll now count 1, 2, 3, 4, 5, 6, 7, 8. Here is 8. So you read it in terms of 1/10 of that. That is 0.0.08. So now if this is a 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, then you have 0.08 is a reading. We are 18. So we are going to do illustration, don't worry. Then we have 8, we have 2. We now add them together, we have 2. So this is how you read that. You have 2 scales. One is vernier scale, whereas the other is the main scale. And so always keep in mind, you read the vernier scale in terms of 0.0, 0.0. You understand? 0.0. I said 1/10. Sorry about that. That is 0.80. I will have skewed that anyway. See, my data is even cleaning and it's everything here. So the first one we use at 2.20. Then 0.0. Is it 80 or 08? Or we counted. So we have this. So that's that about that. Then we move to the last one, which is this. Now you can also get the minimum error or the maximum error. So what you just do is 1/2 of the shortest length which you can measure. I hope you understand. And that will give you 0.05 as the least possible error on that scale. The last one here is the micrometer screw gauge. So a quick one, because we still have, I think we have 2 more slides here. Micrometer screw gauge. I don't want to rush you because it's the foundation class. We have to keep it simple and keep it free. Now, this measure up to what? Even measure is one of the smallest lengths you can even imagine, because it measures up to what? You can keep a note, 3 decimal places. It also has what? 2 scales. One is the main scale, just for quick point, and the second one is the what? Rotational scale, which we call Timbal scale. Timbal scale, or you call it the rotational scale. I hope students have come across a caliper, a screw gauge before. You might have seen that thing they used to, they put inside something like this, very narrow, then they will now be spraying it like this, then to see the dimension. It's very simple to what you can see the picture. The student that prepared the slide here is trying to show us. This is a very good example of this. This is the main scale. You just can't here and look for the point of intersection of that particular thing that is being rotated. When this was rotated, it will align itself with respect to what you have measured here. This is very, very simple to measure. During illustration class, we are going to talk more about that. So majorly, we use this for measuring the central portion. You can say central portion of a converging lens of a lens. So now you are talking about the narrowest of things. Now, about a question that is not asking about the dimension, I ask you which of the following can be used for measuring. What you keep at the back of your mind, my dear student, is how is the size of that thing? If that thing is very narrow, the answer will be micrometer screw gauge. Are you getting it? So, but if you are talking about rods, diameter of test screw is not that narrow, you can use a caliper. So most likely, most of your options we carry micrometer screw gauge, and most likely that will be the answer, because most of the questions you see, and I'm not saying every answer is micrometer screw gauge. So if a screw gauge is there in measuring something that is narrow, it is preferable because it will give you accurate measurement. Something that can measure up to 3 decimal places will measure accurately, more accurately than the one of 2 decimal places. So these are ways we do know right answer as an instructor and as a student that is growing in the knowledge of physics. This is the method I want you to be using. I hope you understand this. So, and about this, we've talked about conversion, measurement of length, and what we use to measure length. We use meter rule, which we call the ruler. We use the vernier caliper, which is also called the caliper. If you use the screw gauge, which you also call the micrometer screw gauge. So this is how we measure length. Length is not the only thing we measure in physics. We also have other things we measure in physics. And about that, we talk about, maybe I should take the next slide to talk about the conversion. Before we talk about dimension analysis, let's quickly talk about conversion. And to do that, let's go into this. Now, about the conversion, I say it's not length, we also measure time. They'll say mass, length, and time. Time, which we said can be measured with different things. You have, let me just list it for you because of beginner. Clock is used to measure time. Another thing you will see in your laboratory is a stopwatch, which often on your phones, you have them. Stopwatch. We use pulse, human pulse, your pulse. You know how to get your pulse. Just place your hand here and all those things. You know what I mean by that. We use a heartbeat. The heartbeat to measure time. And most likely 1, 2, 3, 4. I want to make it 5. There's another thing we call a ticker timer. A ticker timer. So these are what we use to measure time. And about the conversion, a quick one, conversion. When it is not in the SI unit, you want to convert. Be quick to know that in terms of time, you can talk about, you can have 60 seconds. I won't do much numerical, is equals to 1 minute, which I believe everybody should know from their junior classes, but we don't assume. That's why we still need to talk about that. 60 seconds is equals to 1 minute, and 60 minutes is always equals to 1 hour. So we can conclude that 23,600 seconds is equals to 1 hour. You can keep this in mind for now because we are still going to be needed it. And you know, if it is in a day, 24 hours in a day, because an examiner can be funny when it comes to what, trying to what, ask you questions. So keep that in mind also, 24 hours is equals to a day, or you say 1 day. So that's also very important for what conversion, because when we convert. About the other one, we talk about length. Length can be in centimeters too. We can quickly talk about the length because we are considering length, mass, and time. About length, if we talk about length, length can be in meter, 100 and centimeter. 100 centimeter equals to 1 meter. Very common everywhere we go. We have a 10 millimeter is also equals to 1 centimeter. I hope you still remember this. So you can always Keep that at the back of your mind, because this two important stuff is very, very important. 10 millimeter make 1 centimeter. So, and 1000 meter is also equals to 1 kilometer. So the way we will convert is quite easy. For example, I am moving from 1 meter to what? To centimeter, which is 100. How do I get 100 from 1? That means I have to multiply. Simple logic, basics. Now, I'm moving from centimeter into meter. What is in centimeter here, my dear student? If you watch very carefully, 100 is here, I'm moving to 1. What will happen? I will divide by the 100 to get 1. So when you're moving from centimeter to meter, you divide. Look at this. So I'm moving from meter to kilometer. 1000 was here. This is 1. How do I get 1? I have to divide by 1000. So that is how we convert. It's simple. You have to convert something of 5 kilometer into a meter. Say kilometer 1, meter is 1000. How do you get 1000 from 1? You multiply by 1000. So to meter, it should be 5 times 1000. That is 5000. Do you understand that? You have to convert 2 hours to seconds. See, I said 3600 seconds is equals to 1 hour. I'm converting from hour to second. 1, 3006. How do I get 36 from 1? I've multiplied by 36. Just say 2 times 3600, which is 36. So give me 7200 seconds. I told you in physics, you must put the units, which is a subset of quantity. Now, about that, that is that. Then you can say, why do we have to convert? Because we have the international agreed unit, which we call the SI unit, for every dimension you are measuring. This is the basis. Then about mass also, you can think about mass. The most important thing about mass in terms of conversion of masses is 1000 gram is equals to 1 kilogram. You can always keep it in mind too. It's very easy, because if you are having masses, most of your masses will be in what? In grams. Then conversion does not limit itself to mass, length, and time, because you can also convert areas. You can also convert volume. That is where students have issues, especially the A-level students who want to focus. Now, to convert 100 centimeter square into what? Into meter square. Student will make mistake here. Let me help you break it down the way you can visualize it to understand it. So let me say, so far I said 100 centimeter is equals to 1 meter. Then if I'm moving from centimeter to meter, I divide by 100. Student will just divide by 100 and say the answer here is 100. It's very, very 100 centimeters square. From what we've learned in our quantity, square is like area. It contains 2 fundamental quantities. So you can rewrite this as 100 centimeter space, 100 centimeter times 1 centimeter for understanding it, because centimeter times centimeter will give you centimeter square. So this is what you want to convert to meter square. So you have to start converting each of them. 100 centimeter to meter is 1. Then times 1 centimeter to meter. What do? You are dividing by 100. That's 0.01. So this will now give you 1 times 0.01 is what? 0.01 meters. Do you understand that? Because this is 1 meter, this is 0.01 meter. So that is how you are going to talk about when you are converting something of area. The same thing to volume. If I give you 100 centimeter cube, you say 100 times 1 times 1. This is the way we did it. So please keep this at the back of your mind in terms of centimeter square. And then for A-level students, there are a lot of units which you are still going to learn, even for those ones that are just starting, for starters. So all these units, you are going to know them as we are taking the topics, or we talk about them, we give you illustrations, so you keep it in your formula book, then you put a lot of interest. I told you, don't miss classes, because if you miss classes, I mean those in your schools, you have to attend them, listen to your teacher, buy a good textbooks, read through them, then watch videos and put down in it. Physics will be very, very simple. So that is that about that. And to talk about other conversion, which is also very important, which I'm very sure you are going to see, is when you have more than one that is combined together. That is conversion of velocity or speed, as the case may be. Now, basically, we know this is the standard unit is meters per second. but they can be given in what? Kilometers per hour. In fact, I can give you in kilometers per second. It doesn't change anything. So this is the most common one. You are converting from kilometers per hour to meters per second. It's simple. Write it in your simple way that you've learned in junior classes. How do you write km per, that's over hour. You are converting it to meters per second. How many kilometers makes 1 meter? How many meters make 1 kilometer? 1,000. If I'm moving from kilometer to meter, what do? I multiply by 1,000. So that means I'm going to multiply by 1,000. If I'm converting from year to year, then I will now divide it by, I'm moving from hours to seconds. What do? I multiply by 36. I'm also going to multiply here by 36. So the shortcut we give students is by, we say use 5/18. Yes, this is how we come about 5/18 for those of you that used to ask questions from me. This double zero gets cancelled out. 2 can go in 10 how many times? 5. 2 can go in 30 how many times? 18. So whenever you are converting from kilometer per hour to meters per second, just multiply by 5/18. This is the way we do this, which is quite simple. For example, I ask you to multiply to convert 72 kilometers per hour to meters per second, which is the foundational stuff. All I'll do is just 72 times 5/18. It's 18 year 1. 18 3s are 54. 18 4s should be 72. And 4 times 5 is 20 meters per second. And it can be vice versa, like the other way. If it is the other way around, what will you do? You multiply by 18/5. You just flip that stuff. You have your answer. Do you understand? So if it is the other way around, from meters per second to kilometers per hour, just multiply by 18/5. So this is the way we do that. And this is the basis of the way you can get how to convert from any form to another form about the conversion. So we quickly move to the next slide because I'm actually out of time now. So we quickly move to the next one, which is dimensional analysis. This is dimension analysis, fine, which we call dimension analysis. Now, talking about dimension analysis, according to your syllabus, we have to limit ourselves into just the 3 fundamental dimensions, which is mass, we denote by M now, length, we denote by L now, and time, we denote by T now. So mass, length, and time. That is where we are going to limit ourselves to. And about that, my dear students, every dimension analysis, there is aim. We have aim of having what? Dimensions, or dimension analysis. So about that, sorry, I'm trying to control the font here. Now, about that, we need to understand a lot of things. A lot of things. So now, about dimension analysis, you need to know formulas to each dimension. And let it be noticed that you can also keep this as a note that all units, or let's put it that in this way to have a good English, not just for us to write. Now, in physics, you can write it like this: in physics, there are some units. There are some units that are dimensionless. There are some units that are dimensionless. So that is, they don't have dimension. So I said dimension is taken in terms of formulas, and we rate it in terms of mass, length, and time. For a good example, when we talk about dimensional units, those are the ones that has what? No dimension. Now, a good example is when you talk about anything that is relative. Always keep it in mind. I always tell students relative. Most of the unit that is relative velocity relative to the other. So velocity and velocity gets cancelled out. No dimension. The other Relative permittivity. There are other stuff that are not relative, that are also dimensionless. You know, we are taking it from the scratch. And I'm trying to be as simple as I can. So you need to understand that the other stuff, force ratio, velocity ratio, to mention but few. You also have a strain, and so on and so forth. You understand? So keep that at the back of your mind for now. You keep it at the back of your mind that there are some particular units that are dimensionless. Keep that in my mind. So about how to calculate dimension, we can introduce ourselves to some particular ones you need to keep at the back of your mind. You break them down in terms of mass, length, and time. I'm trying to do some things. Now look at this now. Let's start from simple one, area, which everybody knows. Area. About area, we say area is length times length. And what is that? The dimension will be what? You can say in terms of mass, length, and time. This is what L squared. You just want to start from simpler ones. So let's go to the next one. Let's talk about velocity. Before we said velocity is the rate of change of the displacement divided by time. What's displacement? Distance measured in direction, length over time, which is t. How do you write that? Length over time, I say write it as LT plus minus 1. Look at the next one, acceleration. Taking it from scratch, we graduate from there. We say acceleration is the rate of change of velocity. Excuse me, it should be velocity over time. What is velocity dimension? See, LT by 1. You can see LT by 1 raised to power minus 1 divided by t. What happened? That's minus 2. So you have LT raised to power negative 2. Let's take another one. We'll talk about force. You need to know the formula that force is product of mass and acceleration. You know acceleration dimension. What is mass? Mass is also part of the something. So mass is written as, first time we are using m multiplied by L t minus 2. This is it. M is mass times the acceleration L t minus 2. So what I said is all about formula. If you know the formula, you can get it. Work. Now, the work, you can keep all this formula I'm writing at the side here at the back of the mind. It's force times distance. What is force? MLT minus 2 times what is distance? L. What is L times L? L squared. So you write it as M L squared and T minus 2. So dimensional analysis are very important. And I'm trying to talk about basis. Work can also be the same thing as energy. We can talk about pressure, because we've talked about pressure the other time also from formula that was given. We say the pressure is equals to force by area. What is force? MLT minus 2. What is area? Area is what? L squared. See, MLT minus 2 divided by area is L squared. What happened? 1L gets cancelled out this one. So you still have L raised to power 1 here. So you can write it as M L minus 1 T minus 2. So as many that you can write. Now, I think we should write other one, because the common ones you can see, momentum. It's not talked about that. It's about formula. The momentum, the change in momentum of a body, you say momentum is the mass of that body, the quantity of physical mass on the body, and the velocity of the body. You are changing the momentum of your body. That means the product of your mass and the rate of change of your distance with time, which is velocity, is changing. So mass is M. Velocity, we've done it LT minus 1. So combine MLT minus 1. So as many you can think about. Like I said, no teacher will give you all. Others are what you need to know from formula. And as you grow in the chapter wise of this physics, you are going to meet different physical quantities and the formula interpretation to it. Then you can always get the dimension to them anyhow. Then again, another thing, because of the A-level students, which are also watching this, and which is also part of why we have this YouTube channel, you need to understand something which is also important, that you can also get dimension for formulas, non-formula. For example, we consider a simple formula which we might have studied before. Let's take S is equals to UT plus half AT squared is a formula. For beginners, you can just keep this at the back of your mind, the formula. We want to get the dimension analysis. So to get that, we know distance L is, the distance S is what? L. We take it in terms of mass, length, and time. Distance is measured with length. U is velocity. What is velocity? See, LT minus 1. This is time, T. Multiplied by, I'm taking my T to be capital here, multiplied by T. I'm adding it plus half. Then you have times A. What is A? Acceleration LT minus 2 times T raised to power 2. What happened? T raised to power 2, T raised to power minus 2 gets cancelled out. What happened here? T raised to power minus 1 and T gets cancelled out. So L is equals to C, L plus 1 over 2L. This is where I'm going. So you now say 1 over 2L means, you said 1 over 2L means L divided by 2. In dimension analysis, the number here is not taken when you are calculating dimension analysis. So we don't take what the numerical part in dimension. It's also very, very important for you to keep in mind for the A-level students. So you can say L is now equals to L plus L. Now, this is where most students have confusion. And that is why I quickly want to talk about this. Now, if you check this, it is very, but the dimensional what this thing for this formula is correct. What this formula is telling you is that the length of that displacement or the distance X is gotten from the addition of what, two other lengths. So length is equals to length. That is the interpretation you give to it. I get it. So length is taken from what? The addition of two other lengths. So that means meter is equals to what? Meter. This is not equals to 2 meter. And now say 1 over 2 times 2 meter. Then you now say it is what it is. We don't do that in physics. So for every formula you use, we can use dimension to know if the formula is true or false. So those are the applications of dimension. If you are asked to check, we use it to check formula. One of the applications you can also keep to check formulas. Formulas. Another one you can write is what? To derive equation. To derive equation. Because of your exam, you might be asked to write the two words. Importance of dimension. So that is the way we do this. This is what we have. This is the introduction to physics on Mozi Academy channel. We want you to watch this because it's going to help you in your growth of understanding physics. And you watch it according to the way it has been arranged, or according to the way you want it, or you have arranged it in such a way that you are going to get there, even as a beginning. So the last slide show is always our illustrations. Let's see if it is it. Yeah, fine. It is what we are talking about. Now, about this one, you just need to look at this. You are going to do a lot on your own because I can't be doing all this. I told you my students are those that always prepare this slide, and I'm not going to. I've talked about work in the previous slide. I told you I'll just give you the formula. Most of this will be assignment, force times distance. The same thing to energy, force times this. I can be writing the answer for you. Power is force times velocity. You understand? I think this is what I've done. Momentum also, mass times velocity. Impulse is change in momentum. So you can say force times time. See, force, we've done force, mass times acceleration. So I'll just do the ones that I believe you should what? Maybe you are saying, I told you anything coefficient. Coefficient of viscosity. Yes, this one comes out in JUPEB last time, is MLT minus 1. You need to know the formula. Now, beginners, let me do that, a quick one. Now, coefficient of viscosity, we write as the Greek letter symbol we use for that is eta. We use the symbol eta, eta, eta. That's what I said. It's written like this, something like that. So eta is given as, now, for you to even know what we call viscosity, it is just what we say the force, the frictional force that acts in between fluids. I don't know if students are getting what I'm talking about. So it is a force that acts in between fluids. So if you want to get this, you need to know formula. Because if you don't know formula, you won't be able to get the coefficient of viscosity. So the first thing is to know that viscous force depends on different things. There are two factors. I'm teaching what you are supposed to know in what fluids, when we get to fluid. There are other factors that affect, but major factor that affect fluid is the area of the surface and the velocity gradient. Which we call the V by dt, and the V by dx. The S is the distance, which is the length in which the fluid is flowing. So now, if I say viscous force is a force, frictional force, viscosity is a force. So viscous force is proportional to the area and the velocity gradient, which we say the V by the S. I just want to show this for A-level student. For my O-level student, these are what you might be asked as in the basic one. But these other ones we are talking about might be what density is also part of O-level. So for them, yeah, they need it. So if you now introduce a constant, you said that is eta. Then you have A dV by dx. So what I'm trying to say, my dear student, if you make eta as a formula, you say the force is a force. You take it as force. You can say from here, you can say you are saying FV, you are dividing it by A times the V by dx. So what I'm saying is you take this one as a force, which you know the dimension of that. F is MA, that is MLT raised to power minus 1, divided by area is L squared. The V by dx is like velocity divided by distance. I hope you understand. So if we want to do this, F is MA, A is MLT raised to power negative 2. You are dividing it by A is L squared, A is length times length. Remember? N times the V by the V is velocity. Velocity is a distance by time. Remember? LT minus 1. Then you are dividing LT minus 1 divided by S is also distance. What happened? This gets cancelled out. So what do you have under? You have MLT minus 2 divided by, this is a L squared times T minus 1. L squared T minus 1. What happened? 1 L gets cancelled out. Having L coming up will be L minus 1. Look at this, my dear student. This is T raised by minus 2 plus 1. Minus 2 plus 1 is also T minus 1. So this is the dimension you are going to get. About that, I've told you, when you know the formula, it's quite simple to get dimension analysis. So that's about coefficient of viscosity. That's that place. Modulus of elasticity. This is also going to be treated under what? The topic of elasticity. We have videos on all topics of physics. Now, modulus of elasticity is not Young modulus. There are different modulus of elasticity. It's not only Young. You have Young modulus. Some people are laughing. Yes, fine. It's not only Young modulus, but I know it's Young modulus that you guys will know most. We have Bock modulus. Yes, we have Bock modulus. I'm always saying what's Bock modulus. Do we know when you get there? It is not only length that is changing. Volume can change. I get it. And we also have what we call shear modulus. I get it. So note that. We also have another thing we call modulus of rigidity. It's not in your syllabus anyway. Modulus of rigidity is not there. So all these things are what you are going to learn as you go. So, but basically, modulus formula is a shear divided by strain. We denote that by E. That is shear divided by shear should be double E. Tensile stress as Young by strain. Stress, I said shear. Remind me, stress by strain. I'm sleeping on bike. It happens. So the ratio of the stress divided by its strain. That is what we call that. So it's quite simple to get now, right? Because stress is force by area. A-level students, strain is dimensionless. So you're only doing this. Strain is dimensionless. I told you about dimensionless, those that doesn't have dimension. So force by area is only what you want to do. That is that. Then density. Yeah, everybody can do density, both beginners and the A-level. Density is mass by volume. So mass is M, volume is L raised to power 3. So answer will be what? M, L raised to power negative 3. So that's that. The last one is coefficient of restitution. Anything coefficient is what? Dimensionless. I told you. And what we even call restitution is under, for A-level student, is under the topic of momentum. So guys, I want to stop this video because of time. I'm being signaled to stop. So the next question is, which of the following is a set of vectors? What are vectors? Those that have magnitude and direction. I hope you can hear me now. And if you can hear me, let's move on to the last aspect. Which of the following is the correct reading of the figure below? Vernier caliper, the main for the vernier. This is 2.1, 2.2, 2.3. So main scale is 2.30. Vernier scale is point of intersection, which I can't see according to diagram. We need to just see it here. So we have 0.01, 0.02. Where they are touching should be here. So 0. This is 0.3, 0.4, 0.5, 0.6. So 0.06 is where they are touching. You add it together, you have 2.36 centimeters. That is that, and that's the answer to that. So please just look for point of intersection as explained, and that is that. About this one, just read the main scale. The main scale is, this is a gauge 5. So we have we can take 1, 2, 3, 4, 5. This is 5, 6, 7. And 7, this is 20, 21, 22, 23, 24. So we have 7.0. Then we have 0.24. So we can say 7.24. So that is the reading to this. So you can see 0.0. This is 1/10. This is 1/100 of it. So you had main scale to various scale. This is the way we read micrometer, screw gauge, and vernier caliper. So guys, I will stop here. Sorry about some part of the video that is not you can't hear me well. It is because of our network. So guys, you can always follow us on the next social platform. Just search for the name of the academy. You'll be directed to that. So guys, thanks for now. See you soon. Yeah.